Welcome to your first video of 1.4 prime factorization. As we begin this video, you're going to take your notes just like you would in class with me teaching with the board. So making sure that you're copying down everything that I write, set it up. Obviously I don't have paper in front of me, but do your best to follow the lines and I'll kind of give you tips as we go. And eventually it'll stop saying those tips and you'll just realize as you go. All right, let's get started. Okay, we're going to start off with factor pair. So because we're going to use the numbers 2 and we're going to use the number 5. So because 2 is a factor of 10 and 2 times 5 equals 10, 5 is also a factor of 10. So the pair 2, 5 is called a factor pair of 10. Example 1, finding factor pairs. Okay, so for this, you don't have to write all this down because we can just work through the problem together instead of having you write this down, but you'll have it in front of you as you are working on it. But it says, the brass section of a marching band has 30 members. The band director arranges the brass section in rows. Each row has the same number of members. How? That's supposed to say many. Here we go, ready? Look at quick fix. Many possible arrangements are there. Okay, so what you need to do is you need to find and use the factor pairs of 30 to find the number of arrangements. So we start with something like this. So we do 30 and we say it equals. Well, what times what equals 30? Easy enough. 1 times 30. Do it again. What times what equals 30? Let's go to 2. 2 times 15. So you're writing all this down. What's another one? 30 equals 3 times 10. And I got a squeaky pen too. And then another one we could say is 5 times 6. And if you notice, I'm going right down my row here. I've got one. Let me find a pointer here. This is all changed. Oh, there it is. So I've got 1, 2, 3. There isn't 4 times anything that equals 30. 5, and then we could go to 6 again. So I will copy down 6 this time, but normally I wouldn't. We also have 30 equals 6 times 5. And again, now we're wrapping back around. So there could be one row of 30. Let me get my pointer again. So there could be one row of 30 or 30 rows of 1. There could be 2 rows of 15 or 15 rows of 2. There could be 3 rows of 10 or 10 rows of 3. There could be 5 rows of 6 or 6 rows of 5. And those are the ones that we've already listed. So the question says too, how many possible arrangements are there? So there are possible arrangements for the rows and the chairs would be 1, 2, 3, 4, 5. Now, you also have to think we could flip-flop some of these around. So we said there could be one row of 30 and 30 rows of 1. So there's 2. There's 2 on this one. There's 2 on this one. And 2 on this one. So 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 total arrangements. So what we did, though, is we found the factor pairs of the number 30 to figure out how many arrangements there could be. So that's what you're doing in a problem like this, is listing out those factor pairs. Let's try a couple. So if I said, list the factor pairs of the number, and I give you the number 18. So what I want you to do is list the factor pairs of those numbers. Go ahead and try it on your own. So you're going to pause the video, because I'm going to pause it myself, list them out. So make sure you pause before you move on. So there are 3 factor pairs for 18. We have 1 times 18, 2 times 9, and 3 times 6. So we would list them out like this. 1, 18, 2, 9, and 3, 6. Okay, let's try 24. So I want you to go ahead and pause the video, try to list all the factor pairs, see what you come up with. Okay, there should be 4 factor pairs, 1 times 24, 2 times 12, 3 times 8, and 4 times 6. Another way to do this is to do a T-chart. And with a T-chart, it's just easier to kind of see what it looks like, and I'll show you how to do that right now. So you put 24 at the top, and you do a little T like this, and you think of all the different factors. We already said that there's 1 times 24. Then you go straight down, 2. 2 can go into 24 12 times. 3 can go in 8 times. 4 can go in 6 times. Then you think about 5. Can 5 go in? No. Can 6 go in? Yes, but we've already done it. It's right there. So we've got 1, 2, 3, 4 different factor pairs of 24. Here's a little moment I want you to remember. So you're going to write this down, but we're going to talk a little bit about what a prime number is. So make sure you're jotting this down, please. A prime number is a whole number greater than 1 with exactly 2 factors, 1 and itself. So please write that down, and then we're going to talk about a composite number. A composite number is a whole number greater than 1 with factors other than 1 and itself. So an example would be, and as you did the number board earlier, an example would be let's do a prime number first. If you can only find one factor of a number, and so it's itself and it's 1 and that's it, then that becomes a prime number. So let's look at the number 5. So 5 equals all the factors that you can think of is 1 times 5. There's no other factors that 5 has. So that becomes a prime number. Composite number, let's look at 6. So 6 equals 1 times 6. And you've got 2 times 3. So because there's another factor besides 1 in itself by 2 and 3, it becomes a composite number. Here's our key factor. Yep, go ahead and draw your key. Make sure it's a good one. Do my best on the iPad. Yeah, that's it. It could use some work. It's fine. Okay. So the prime factorization of a composite number is the number written as a product of its prime factors. Copy that down, please. So you can use a factor pairs and a factor tree to help find the prime factorization of a number. The factor tree is complete when only prime factors appear in the product. So I'm going to show you an example of that, and we're going to finish up this video. So if I wanted to find the prime factorization, which is the number written as a product of its prime factors. So what I would do is I want to try to find the prime factorization of 60. So what I would do is I would start with what times what equals 60, and you can do any of its factors. I'm going to start with 2 times 30. Okay, a lot of times I ask that you put the dot in between so we know that that's the factor. So now what we want to do is we want to get it down to all the prime numbers we can. 2 is prime. So usually prime numbers are odd numbers. However, 2 ends up being even, but it is still considered prime. So now I have to keep going, and I go off of 30 because that is not a prime number, because I know that 2 times 15 equals 30. So I'm going to circle my 2 because I know it's prime. Always circle the prime numbers. And then I have to try and think of factor pairs of 15. So I think 3 times 5 equals 15. 3 is prime because there's only 1 times 3. And 5 is also prime because there's only 1 times 5 that would work. So now what I do is I take my 60 and I say it equals, and I write down all of my prime numbers. 2 times 2, there's that first 2, there's the second one, times 3, times 5. What I would really like us to start doing is writing it like this, though, because I have 2 2's, I can write them as a power, right? I can use my base of 2, and I can say to the second power, because there's 2 of them, there's only 1 3 and 1 5. So this is my complete answer of the prime factorization of the number 60. 2 squared times 3 times 5. This concludes our first video. So we'll kind of talk about what to do after this, but your notes should look just like they have in class so far, and I trust that they do. Good job.